All right, so let me just show you this. We're going to do this Friday, but in case you're watching this after Friday, and we should know all these things. So there's going to be some equipment on the test that you should be able to identify. The Bunsen burner we just did the lab on. Hopefully you know what that looks like now. The Erlenmeyer flask is very important. It's got a wide base, so that's very stable on the bench, and that's helpful for having a liquid not tip over. The problem is if you're going to heat up in here, you're going to have sort of this volcanic situation happening. So if you're heating something up, this is better. The beaker is better because it has a wide mouth, so there's room for steam to form and whatnot. Beakers are also helpful. Unlike Erlenmeyer's, they have that nice little pouring spout. Test tubes, you should know. Crucible and a crucible cover, you should know. A watch glass basically looks like a giant contact lens. Tongs, you should know. Wire gauze, we did already stuff with. You should know that. Safety goggles, self-explanatory. This graduated cylinder we will use to measure out liquids. It's very good for accurately measuring liquids. These pipettes, we're not going to call them micro pipettes. Let's just call them pipettes. Those are good to know. A funnel, you should know. Scopula and spatula are good for moving solids. You should know that. That could be a nice little multiple choice question. So those are the things you should know. I don't think I'm really worried about, well, I guess we'll use a 24 well plate. The reason you should know what that is, I think, is if you ever do anything with biology, they're popular. What they are is basically very small test tubes, and we'll be using those this year. But it allows us to do a lot of cool chemistry without a lot of hazardous waste because they're so shallow. You can still see the reaction, but you don't need much material. All right. So chemistry is the study of matter, and matter is anything that takes up space and has mass. And we talked about my daughter playing this little emoji game where they run through all the characters you can get with a gold box, and she thought there was a reason for that. And if you hit this button here at the exact right time, you would get either the thing that just showed up or something, that there was a relationship between when you hit the button and what emoji you got, and she wanted Moana. So using the scientific method, her question was, does hitting the button in correlation to which characters are showing relate to which character you get when you purchase the gold box? That was her question. And then the next thing she did was research. She looked it up on Google to see if there was any known relationship between when you hit the button and what character you get. And there wasn't. So then she had a hypothesis. That was, if she hits the button right when Moana shows up, then she will get Moana out of the gold box. That was her hypothesis. The experiment she did was she would gain, she would save up the coins to buy the box, and then she would hit the box right when Moana would show up. And then she would observe. And what actually happened was she wasn't getting Moana, but she started recognizing she was getting something about 3 or 4 emojis before Moana. So those were her observations. And the variables were exactly when she hit the button. It's hard. Those things, if you ever played that game, they pop up in half a second. So it was hard to hit the button exactly right time. So her analysis of her data after doing this a few times, and her conclusion was it might actually be related to the one a few before. And then she tested that hypothesis. So from there, you can go back to a new hypothesis. And so that's what she did there. All right. So you need to know this. Hopefully you learned that already. And then we talked about what types of observations you can make. And there's quality and quantity. And hopefully, since this has the word quantity in it and this doesn't, quantity involves numbers. So qualitative observations are anything that are non-numeric, strong aroma, medicinal taste for this glass of stuff here. It's a green color. Those are not numeric observations of that glass of stuff. Quantitative would be anything that you can measure. So the temperature being 30 degrees or the volume being 300 milliliters or the glass being 8 inches high would all be considered quantitative observations. So I might have some multiple choice thing about that. Independent variables we talked about today. We said that independent variables are what it is you're trying to test. So in Chelsea's case, the independent variable was, does when you hit the button to buy a gold box allow you to select which emoji you get? And the dependent variables would be which emoji does she get in that case, the results or outcomes. And constants would be factors that do not change during the experiment. So again, these are definitions. I'm not going to ask you to spit these back out at me. What I'm going to ask you to do is be able to apply these things. So if I asked you to do an experiment, does coffee help test scores? I'm asking you to determine what's the independent or manipulated variable. So the independent variable, someone properly said today, it was maybe Lillian in sixth period. I don't know. But anyway, she had said that whoever it was, that the independent tends to be comparing things. And in this case, you're comparing coffee drinking students versus non-coffee drinking students. That's what the experiment's looking at. Okay. So you're looking at a group versus another group. Or if you're going to say, does adding a chemical make something happen versus not adding the chemical, right? That's the experiment. So the independent variable is sort of what is it you're testing? And then the dependent variable is what is the response you're expecting to get? So in this case, with this coffee help test scores, the independent variable would be drinking coffee versus not drinking coffee. And the dependent, what you're going to measure is whether the score on their test increases or decreases with the coffee. And the things that you want to hold constant in that case. So you're doing this to make sure that the only thing that's affecting the outcome, which is the score on the test, is really just the coffee. So you want to make sure that the test is the same, that one test wasn't harder than the other, and that's why people didn't do the same. Or that the coffee drink is the same. You don't want people having low coffee, diluted coffee or strong coffee. You want them all to have the same. Eric mentioned, I think it was Eric, that you want to make sure the ones who are not drinking coffee drink something so that you can say it's the coffee. It's not the act of just drinking or staying hydrated. And I thought that was a great point. So the people not drinking coffee should also have a certain amount of like water to make sure that that's not the thing that's making the test change. The same age as students. You don't want one group who's taking a math test to be younger than the other group because maybe that's the reason. The same gender, and when we said that, we want the same gender breakdown. You don't have to have all the same gender, but you can't have 60% of females in one study and 40% of females in the other group. You want to make sure both groups are representative, ballpark the same gender, and same study habits as well. You don't want all your A students in the coffee drinking group and your BC students in your non-coffee drinking group, because that already might be the reason there's a difference on the test, not the coffee. So you want to make sure that students' study habits are the same on one side or the other. And constants are not the same as controls. You may have heard about a control group. It's the group that's not subjected to the independent variables. So in this case, that would be sort of the non-coffee drinking, water drinking students. So you make sure that just drinking water doesn't give you the same result as drinking coffee. All right, then we talked about changes, which I think is where I'll stop right here so that you don't have to deal with long videos. All right, there you go, Kate.